we saw a good deal this morning about different visions for 6G, but that only happens within the technology context. And if you're paying attention to the people there, then you could think that 6G extends across all kinds of technology areas and pretty much encompasses everything. But in practice, we already see major shifts in the telecoms ecosystem and the technology innovation, which 6G is going to pick up on, potentially, but which exist independently of it. And so during this upcoming session, we've got a couple of different areas. I'd like to start off with a conversation here between myself, Irfan, and Izzo, where we're looking at some of the work they're doing beyond a purely 6G play, and how that fits into any direction that we take. And then after that, we'll bring Ellen Xenti from Eurocom, who'll be talking about LLMs and AI, that in the context. So first of all, I'd like to start off maybe by getting Irfan, if you can take a couple of minutes to introduce yourself and what you're doing.
Thank you, Alex. So my pleasure to be here. I guess, you know, coffee and other stuff that Eurocom has provided for this event is very good. And that's why, you know, people are hanging out outside. But yes, you know, it's a pleasure to be here in this room today. My background is very connected to Eurocom. I was a graduate student here almost 25 years back now. So back in 1996, I joined Eurocom as a graduate student, and then you know, over the years, when I graduated back in 2000, I have had the honor or the privilege of working for some of these big telecom companies of our times. Those were the 3G days, so you know there was a lot of enthusiasm about that at that time, about telecommunications and mobile communications for the most part. You know, technology has really come on a long way after that, but the fundamentals have not really changed very much. Now, you know, after having worked for all these companies, big names like the Intels and the Ericssons and, you know, whatnot, even Motorola, I came back to take charge of open air interface operations at open air interface software lines. Now, open air interface is as some of you already know, is a great success story of Eurocom. It's a project that was created at Eurocom back in the 90s, late 90s. Since then, it has really been adopted by, you know, even industry. A lot of research is using it, research that was 4G and now 5G and in the future 6G. Lots of prototypes are being built on top of that. So, you know, open air interface is a very important central project in the path towards 6G. What I believe is that prototyping is very important. You know, when you start showing new technology, you should be able to showcase, you know, what works and what doesn't work in terms of new technology. And, you know, having an open source project like Open Air Interface is really very valuable there, as many of the folks here will testify. So yeah, that's pretty much what I wanted to say as intro, a bit long-winded as always, but right.
Thanks very much, Irfan. And Izzo, perhaps you can, yeah.
All right, hello everyone. My name is Izzo. So just in case someone tried to speak French on my back, it happened past at some meetings where people didn't know I spoke French fluently. I went to school here, I went to undergrad in the US, my grad school here at University of Nice, Sophia Antipolis. I worked across street for NXP Semiconductors. This is back in 2004, and I left in 2007 when the iPhone came out. My area of expertise is really around secure element. That's what NXP did. Customers were Gemalto today, we talk about Thales, And it's been always over the past, I would say, 20 years, thinking about building end-to-end system that comes from the secure element to a cloud. So you can think about NFC application, but you can also think about a mobile application, a mobile network, because it requires a secure element, that's the SIM card, and it requires also a server component, and that could be the network. So we fast forward. I had a few startups. I worked for AT&T. I was AT&T SIM card product manager out of Atlanta, and I started as a troublemaker. I started a company. The idea was to kill the SIM card. Because after all these years, I grew to actually start hating the SIM card, and I wasn't the only one. Steve Jobs is known to hate the SIM card. In fact, there's been many battles within Etsy to make the SIM card get smaller. That was the nano SIM battle. Some of you may remember. There was also a battle that happened after Steve Jobs passed away, which was about electronic SIMs, getting rid of the SIM. That was a big battle. A lot of people said we'll never have an eSIM inside a phone. Like I said when I was making an earlier joke, going to those Etsy meetings, people were like, big operators, I won't name them, so no hard feelings. They're like, what is this cockroach doing here? We're never going to standardize the eSIM. It's never going to happen. I feel vindicated nowadays because it happened. We have eSIM everywhere. And then you start wondering, right? We sold the company in 2018. We're like, okay, now it's eSIM we want. What's the next step in evolution of the SIM? And what's interesting, I think, for the folks that are part of Etsy, they will also see that Etsy has changed the smart card platform team, committee, and now it's called the secure element technology. And that's very interesting. It happened in 2022. What it means is that we no longer talk about a chip inside the device or the user equipment. This now is we call an integrated chip. So that would be within the system on chip, right? So that means now, let's say if you buy a Qualcomm system on chip, you won't buy a removable or an integrated UICC from Thales or any other vendors. It will be within the system on chip itself. So the SIM has completely faded away, right? But what hasn't changed since the 90s, though, is the content of the SIM, the way it authenticates with the network. We're still using symmetric authentication. The same key inside a SIM is also the same key inside the network. And that led us to, when we started this company called Bloxtel, which is our new company we started about 2 years ago. The idea was, we said, what are the open source projects? We saw Open Air Interface, we saw Open 5GS and all those projects. We said, oh my God, I can actually run an entire 5G core. That's very high. So please tell me, so if the whole 5G network can run inside of Raspberry Pi, why are we deploying it in many big data centers and whatnot? It's very provocative, but if you start thinking about that, say, I can run a 5G, entire 5G system. I'm talking about all the network function inside a Raspberry Pi. Why are we deploying a data center? And then the more I thought about it, and we said, oh my God, it's because of the SIM. The specific SIM, because since the 90s, the way we do keys in a SIM is the same keys inside some sort of database. Even we're talking about 2G, 3G to 4G to 5G. We've built all those crazy server component, and now we have this service-based architecture with 5G. It's because of that. And for us to simplify it, to make it look like Wi-Fi, we said, well, what needs to change is the way you authenticate with the network. So I'll just start with that. That work actually started changing because within 3GPP release 15, there's been some contribution. Albeit 3GPP didn't want to do that, they enabled the BAP TLS, which means you can actually do certificate-based authentication. But 3GPP said it's only for non-3GPP devices. And our vision for 6G is to actually make it for 3GPP devices as well. That's what my company has done.
Great, thanks, Izzo. So I am going to make sure that you will get the chance to chime in as well if you have questions. But it seems to me that in both of your cases, you're looking at the telecoms world more through the lens of IT and software rather than a sort of traditional network engineering approach. And that implies, I guess, a world that's more open to, for example, developing services quickly, testing them out, modifying, a world of things like GitHub, which is very different from traditional telco approaches. And maybe you can help us understand how you reconcile that, or if you see any kind of clash of gears there.
Yeah, maybe I can say something about that, a little bit provocative maybe, but this is an industry. We spoke about 2G, 3G, 4G, 5G, now 6G. This is a very low innovation industry. There has been no innovation in this industry, really, when you look at it during all these years. Innovation is very, is a word that is used a lot, but innovation only means one thing. It means changing the market. And the market has not changed when you look at how things have evolved from the 2G, 3G times. It's the same set of incumbents in the market, the service providers, you have the big vendors, and that's why things like or initiatives like Open RAN, ORAN started, because basically you want to change this market so that the strategic boundaries of the industry can be changed and new entrants, substitutes, etc., can enter the market, right? And I believe that is where we need to invest as we go towards 6G. IT, you spoke about, is an important component because now this segregation can happen in the networks. When open air interface came to at the advent of open air interface, it just couldn't run on any of these general purpose equipment or servers, but now it can. And the entire industry, even established players, want to run everything in general purpose compute. So now there is a possibility of really innovating in this market by opening up the interfaces, which has already been done. And now it's a question of having the economic sense of all of this to come together so that there can be innovation in this market finally. So 6G is probably the right time for us to innovate in this market.
That's fascinating. And then, Izzo, how do you find that? I mean, as you said, you've been playing as a disruptor in the market already. And if we look at distributed networks and so on, it's one thing to take, for example, a very centralized telco, provide more capabilities, for example, at the edge. The potential, though, seems to be very much more distributed than that. And I just wondered to what extent you find the way of doing things that you're working through gets pushed back in the market.
I think, to me, we talk about non-terrestrial networks, I think, earlier today, but there's a big elephant, just for using, I guess, the term that was used yesterday, that we're not addressing. There's this new breed of operators that are emerging. I mean, altogether, we have probably less than 1,000 public operators around the world, but there's actually a new breed of operator that exists. They already exceed the thousands. And they're going to probably hit the millions by 2030. And I'm talking about enterprises. I'm talking about private. And here's the thing that I found out, right? And the reason we were not thinking about the 5G network, it was just about, okay, SIM, that's interesting. Talk to enterprise customers. They all tell you, we already have wireless connectivity, the IT admin or the CIO. It's about, they have Wi-Fi. They have reliability problems. They've been exploring cellular. But the first thing they say, oh my God, we love cellular, but boy, it's too complex. It's just too complex. It's a monster, right, to deploy a network. And to us, that was, okay, that's the gold standard for us, right? Okay, how to build a 5G network, a 6G network that enables this new breed of operators, because this new use case we're talking about, even when we talk about robotics, there is going to come from specific vertical market and enterprise that need that. And those are over-the-top players, enterprise that have specific applications. We need to tailor enabling 5G network deployment in a way that's completely different. It's very interesting when I see cloud native, everything cloud native, and I'm like, why do we think about cloud native when I just said I can run this whole thing on a Raspberry Pi? If you think about a Wi-Fi access point today, what's inside a Wi-Fi access point? There's a radio. There's what they don't call it, but we could call it, as telco guys, we can call it a Wi-Fi core. It's running inside the access point. There's no data center. Why can't we have that for telecom? Why can't we have that? This is not me asking that. This is what the enterprise asks because he has the money. He understands Wi-Fi, and that's why he's telling the telco guys. When he called the big operator, has no answer, calls his big vendor. And the big vendor, oh, you got to talk to my SIM card vendor, and they gotta get all it's too complex. It could be simple, and I think that's where, to me, allows me to look at the whole industry from a different lens, just being kind of the voice of the customer.
That's really striking, and I think it picks up on some of these things that 3GPP have been talking about recently. You know, telcos in there coming in and asking for simplification in 6G, which seems like a crazy ask given what we've seen of the different requirements that are coming from different backgrounds. But if we are able to find simplification and cost efficiency, presumably it has to lie in some of these different operations or different mindsets. So I'd be curious, maybe Irfan, you can take this first, but where you see your work contributing to that. And obviously it's not just a 6G problem, but it's one which is only going to become basic in 6G if we can develop it in a way that delivers on all these metrics.
Yeah, so, Raymond, my colleague, and, who's the president of Open Air Interface Software Alliance, a professor at URICOM, also was supposed to sit on this panel. I just am, stepping in for him. And so maybe, I should say something that he always says. Basically, we have not done 5G yet from, what the capacities of 5G, the sort of the promise of 5G was to densify the network, and basically what we are doing even in OAI at this stage in our small scale lab setups or even some outdoor setups is just baby 5G. We have these 4x4 systems, etc., that are deployed out there, a real 5G would have been things like massive MIMO, being able to direct beams at users, beam switching, and densifying networks so that you can throw lots of traffic or data rate at individual users. It's just that the applications probably were not there, or the economics. In fact, I was in Austin the other day at one of the events where people were asking this question. Eric Dahlman and Stefan Parkwall were there, and they were speaking about these are the sort of the big names in standardization. They were there to speak about 6G, and people were asking them questions about, why 5G, why 6G now? And they were saying, there were questions like that were being asked, why have we not done small cells and things like that? So I think, the economics of all of this is not making sense, I believe. And so, from the perspective of what 6G will be like, or, what 6G will address, I think it'll be good to take a step back and, sort of think about, as you said, where is the use case? I think it's probably at the in the private 5G space. There's a lot to be done. I personally don't have much against data centers. They don't have to be huge. They can be micro data centers. We deploy some of them, and we have seen some of these factory use cases. They are pretty small scale data centers, locally located. So it's just a few compute servers, right? And so yeah, that probably has good economic sense. And in terms of the applications, I think that's what we should be looking at rather than technology. It's not really about technology, as Raymond says. We haven't even explored 5G properly yet.
So I'll turn this over to the audience here. We've had, I think, a few fairly provocative statements. So if anyone here would like to argue, throw stones, ask a question, that kind of thing, just let me know, particularly with the stones, so that we can get out of the way. But yeah, if you have something to say, raise your hand and I'll come to you. Otherwise, I'll very happily carry on chatting away here. But I wanted to make you aware of that. We've got about another quarter of an hour or so. Now, there was something that I wanted to pick up on. Oh, here we go. Here's Dean. Yeah. So one of the things that I'd like to ask about is if we are able to go down a route that we've already heard people talking about and advocating in terms of becoming much more based on software, much more based on AI, then we start to end up in a position where from that commercial basis, what is the telco? Are they the IT provider of these things? Are they the holder of the spectrum that these other players need? I mean, when you're thinking of the implications of what you're doing, are there sort of particular nightmare scenarios where you think we could do this, but if so, for example, the funding for the Open Air Interface Alliance and so on will get cut overnight, and I'll be exiled. I mean, where do we go, do you think?
So, everything is, again, I keep talking about this, like repeating myself, but maybe, some of the Etsy folks, if you speak to them, and this is again, at one of the events that recently took place in Etsy, what is AI going to bring, right? That's one of the 6G tracks or the enablers of 6G. What it brings simply is cost reduction as a first instance, right? That's how the service providers and others are looking at it. So basically, this brings us back to what I was saying earlier. The economics of this is not making sense. And that's why, cost cutting, energy saving, and all those different aspects where AI can help are probably going to be the first applications of AI. Outside of that, if I know, university researchers are looking at AI for many different kinds of things in networking to improve the performance of the algorithms themselves, channel estimation and all those kinds of algorithms. All that is good and probably will deliver. I hope it will, and the overall performance of the network, etc. But right now we are only looking at the interest of these advanced technologies, AI included, AI being the central one, for cost cutting, right? So in a certain way, we are trying to fix the problem of, the economies of this thing not working. That's the problem we are trying to fix at this stage in the late 5G times and the early 6G times. That's my view where this stands.
Just kind of maybe too earlier what you said about the data center. I don't have any issues with the data center, but when I think about it is when my customer, right, he's not your regular operator, but he's saying, I want to deploy my own private 5G network, right? He already admitted internally that 5G may be better than Wi-Fi, or at least complementary to Wi-Fi, right? And he says, okay, it's complementary to Wi-Fi. I see network slicing, it's much more reliable and all that, and he's all for it. But the reason I'm saying the data center part, it forces you, right? I think that's what the industry doesn't do, because it's like, I hate to say that. Every time there's a 1G, there are a lot of people make a lot of money. Someone at Apple told me once, he says LTE doesn't stand for long-term evolution, employment, because people make a lot of money of it. So we see a lot of white paper, but is there this 30,000 feet view of what have the industry built? Is there a way to, instead of evolution, could be a revolution? And rethink all the other stuff that we built with this new class of operators, right? And I think that's what doesn't get addressed. And when you start thinking, say, okay, what if I take the whole 5G network, run that inside the box? Although I can do that in a data center, it first start thinking, okay, oh my God, this whole thing will be simplified. And what do we need? Because an enterprise, when they deploy a private 5G network, it's not, the connectivity is not the application, right? It could be a robot, an AMR within the warehouse or whatever that is connected to that network. When you think about even a Tesla car today that constantly send a lot of data back to their servers, once they find out actually latency, although they build their own TCP, which is Tesla protocol instead of TCP, they don't realize, oh, it has to hop into the other operator's server before it reaches my server. Right, and now I'm seeing solution today. Oh, we can put UPF at the edge and all that kind of stuff, but we don't want to address what I think is still the elephant in the room, is that the way the architecture at the core level it's been too complex. It could be simplified.
Great, thanks very much. I'm aware Dean did want to ask a question, so there's a lot to pick up on there. But Dean, if you want to just shout out, then I'll repeat a summary for the people online. So in other words, if we think about those monolithic national scale networks, it sounds as though there's already a lot of scope for them to be cut away. Should we be designing 6G for entirely different kinds of networks?
And I think that's just what I kind of, yesterday, for the people that were at the ETSI meeting, I kind of asked this question. I was a little bit humble and probably relatively shy on expanding on that question. I said, why if the ETSI just put all the 3GPP spec implementation instead of having open interface? We got open 5GS. We got so many open source projects out there. Just do a reference implementation of it on GitHub, and then have pull requests instead of having meetings in Korea and whatnot. Yes, we can standardize it, but just like the way the open source community does it. And the reason I kind of asked that was, if you're saying, some people even said, why even we need another G? I heard that like from enterprise, why do we need again another 6G? I mean, for the customer, yeah, okay, it's a 6G appears, the marketing team at the operator love it. It's a way to sell to the customer, but for the existing customer, they see the value of 5G, but why do we need to set up new standard? Why if we just can actually tweak what we already have and their iteration, instead of having 6G or 6 is 5.1, 5.2 or whatever, 5.3, it changes you, and then we can iteratively improve because we have a new constituent of customers asking for those. I think that's a different way of thinking about it, but it's come from an IT landscape, looking at it, instead of just saying, oh, this is how we've been doing for the past 20, 30 years. Who are you guys to say, change it? But open source, hyperscalers, the way they think about telco, you've seen today, right? The meeting in Korea is not just the traditional vendors. You have hyperscalers now interested in this. It's a different way of thinking about it. I think, to me, to answer Dean's question, it's 6G should be happening now already.
Yeah, so, this is a good question and a good remark. The coexistence of the networks, that's a bit of a problem right now. We speak about these new operators, small ones that will operate their own networks in private enterprise factory type networks. And that's a very interesting use case. I think that is, in fact, the market that probably, get 5G and maybe 6G later going, especially with lots of AI type applications. The problem is the spectrum also. Right? That is also something that is very tightly controlled. So, this is an industry where we are seeing lots of regulation here, right? Regulation is very, very tightly or very, strongly present. When you think about deploying those networks, what frequencies are they going to operate in? It's an important question, right? People speak about CBRS. I personally don't know the details of how all this works, but the dynamics of CBRS, but it's not straightforward, CBRS either. And these expensive frequency bands where, it actually matters, propagation works are all national level networks. And, these are the kinds of things that are probably in the minds of everybody who's speaking about how to change this market innovation. The NTIA, the Department of Commerce in the US, they recently put out two, in fact, calls for proposals in Open RAN wanting to open the market, having multi-vendors and vertical industry use cases. And in fact, one of the fundamental questions that the private industry, private 5G asks is, what is this going to operate on? And we still need to have a service provider like Verizon or whoever to show up and basically give you a part of their frequency band to be able to operate all of this, right? So that's also something that is, I think, for adoption, for innovation, that is a challenge. So how these networks are going to coexist, and in the US there's a fight also with the military folks, right? They have all these bands that they don't want to give up. So yeah, it's going to be a hard problem to solve.
Yeah. So thanks very much. Anyone else wants to chime in on that? Because otherwise, I have to say this. Yes, problem of innovation. You're not the first person actually to flag this up recently. As a quick puff, Telco Forge runs these executive level meetings under Chatham House rules, where very kindly executives can talk fairly openly, and then we publish the results in an anonymous way. And just in the last couple of weeks, one of these people was saying, telecoms is where innovation goes to die, which is quite a cell phone. But if we are to change things, how do you see the opportunity there to make the industry better, to make it more dynamic? I mean, is this a case of trying to change perceptions at the top level, something, so that they're able to embrace uncertainty, chaos, so on, or are there actually sort of opportunities from the grassroots that you see as well to almost sort of force these changes on the industry?
So just to answer, and I'll add actually on the other part, I was in an agreement actually that, like, in the US, we mainly focus in the US market, we have CBRS. So to me, as a developer, as an engineer, I have everything that I need, right? I have my own 5G core. I can build my own SIM. It's using eSIM, my own profile, and I have CBRS, right? And using the spectrum acquisition system is not perfect. It's advanced enough that now within the same access point, I can leverage, and also with the CBRS 2.0 that is being elected in the US, depending on certain height, it's automatically granted to you. So I have all the toolboxes to enable my customer to become an operator. But having said that, I think to us, once you start getting outdoors, that's become a problem. That's why I talked about this Tesla use case and whatnot. And I think then it comes down to, okay, so I don't need to go to the operator. They don't build anything, by the way, so to say. So I'm like, okay, for the enterprise customer, the reason we're going back to the operator, they just happen to have the spectrum, right? And maybe to me, the next innovation is about new ways to share this telecom infrastructure, including spectrum.
Yeah, so definitely spectrum being one of the big problems in these newer markets, and this was discussed also, Ben, when we were in Austin, and some very heavyweight researchers from the industry as well, academia, were present over there, and somebody asked this question. Andrea Goldsmith was on the panel, and people were asking this question that. This joint sensing and communication has been around for 20 years, and what will we now need it probably more than we needed it at that time, but there is really nothing today that actually dynamic enough that will where it works. We don't have techniques to make it work, at least not at the level of where we need for it to be deployed or adopted by industry. So yeah, if there are intelligent ways of doing ISAC or ICAS work, that'll be, that's a topic maybe for National Instruments, right? Yeah. So yeah, that will definitely help. I think the only way to innovate is going to be to operate in what they call blue oceans, right? Which means that you don't go into the space of the established service providers and vendors, because that's a very hard, difficult place to change, the practices of. So anything new will happen in these spaces that you spoke about, Izzo, in the private networks and maybe tier 3 type, where we are also prepared to sacrifice some of the performance requirements. It's not so easy to do that on a factory floor, but maybe there are other places where it can be done. And disruptive innovation often works like that. You build a product that is of low grade. Basically, you do that on purpose, right? That's how disruptive innovation works. So that it finds its market that is at the bottom end of the industry. And then over time, it moves up when performances improve and other parts of the industry are prepared to adopt it. So yeah, we should probably be looking at disruptive innovation. We should build crappy products, maybe. That's what we should be doing. And have them adopted by somebody in this telecom market.
Well, that's certainly a disruptive idea.